Everyone, I am Janrel L. Rodriguez and my partner is Lawrence A. Sumargo, and we are assigned to report or to discuss about Theorem 6, which is the quotient rule. So in quotient rule, if u of x and v of x are any two functions which have a derivative, and if f of x is equal to u of x over v of x with v of x is not equal to 0, then f prime of x is equal to v of x multiplied by u prime of x minus u u of x multiplied by v prime of x over v of x squared. So the derivative of a quotient which is a quotient of the two function which is the u of x over v of x is the denominator times denominator katong v of x, then multiplied by the derivative of the numerator which is the u prime of x minus numerator times the derivative of the denominator, all divided by the square of the denominator. Proof. We proceed by the three-step rule. Step 1. Delta f is equal to f times x plus h minus f of x is equal to u times x plus h over v times x plus h minus u of x over v of x. We may write u times x plus h equals u plus delta u, and v times x plus h is equal to v plus delta v. Therefore, delta f is equal to u plus delta u over v plus delta v minus u over v. Then we need to subtract, so becomes delta f is equal to v times u plus delta u minus u times v plus delta v over v times v plus delta v. So after that, um, we we did some algebraic solution, so it becomes delta f is equal to v delta u minus u delta v over v is multiplied by v plus delta v. So in step 2, delta f over h is equal to v over v times v plus delta v multiplied by delta u over h minus u over v times v plus delta v times multiplied by delta v over h. Then in step 3, h kanang gihimo ang h nga nag-approach sa 0, so limit of h as a limit of delta f over h as h approaches to 0 is equal to f of x equals v times u prime minus u times v prime over v squared.
So let's now proceed to the given example. Find the derivative of f of x is equal to 2x squared minus 3x over x squared plus 3. We recognize that the function is of the form one function divided by another, and we set u, which is our numerator, 2x squared minus 3x, and v is equal to x squared plus 3, which is our denominator. Then we take the derivatives of u and v. So u prime of x is equal to 4x minus 3, and v prime of x is equal to 2x. So we use power rule in finding the derivative of u and v. So now by theorem 6, let's follow the formula f prime of x is equal to v of x times u prime of x minus u of x times v prime of x over v of x squared. So we simply substitute everything. So f of x is equal to v of x, which is x squared plus 3, times u prime, which is 4x minus 3, minus the u of x, 2x squared minus 3x, and v prime, which is 2x over x squared plus 3 squared, which is our v of x squared. Then, then we now simplify the numerator. So, x squared times 4x is 4x cubed. Then, x squared times negative 3 is negative 3x squared. Then, 3 times 4x is equal to 12x. Then, positive 3 times negative 3 is equal to negative 9. Minus 4x cubed minus 6x squared over x squared plus 3 squared. Then, we simply substitute the negative sign to the next terms following it. So 4x cubed becomes um, multiplied by negative sign is simply 4x cubed. Then negative times negative 6x squared is positive 6x squared. And then let's now combine like terms. So we can cancel this 2 4x cubed. 4x cubed minus 4x cubed is equal to 0. Then next is negative 3x squared plus this 6x squared can be subtracted and it will become 3x squared. Then let's copy 12x, then negative 9 over x squared plus 3 squared. So this is the final form of the function.
So we have an additional example. Number 1, find the derivative of g of x is equal to 5x minus 1 over x squared minus 2. So we have u is equal to 5x minus 1 and v is equal to x squared minus 4. Then we need to get the derivative of u and the derivative of v. So the derivative of u is equal to 5 and the derivative of v is equal to 2x. Then here's our formula in finding or getting the derivative of the quotient rule. G of x is equal to v times u prime minus u times v prime over v squared. Then substitute all the given. Then g prime of x is equal to x squared minus 4 is multiplied by 5 minus 5x minus 1 is multiplied by 2x over x squared minus 4 raised to the power of 2. Then we need to expand and it becomes x squared multiplied by 5x, so it becomes 5x squared minus negative 4 multiplied by 5, so it becomes negative 20. So then copy the negative minus sign. Then 5x is multiplied by 2x, so it becomes 10x squared. Then negative 1 multiplied by 2x is equal to negative 2x. Then copy the denominator. Next step is we need to substitute the negative sign. So copy 5x squared minus 20x, and then negative multiplied by positive 10x squared is equal to negative 10x squared. Then negative is multiplied by negative 2x, so it equals to positive 2x. Then copy the denominator. Next step is we need to combine all like terms, and then ato silang i-plus or i-minus. Then 5x, ang like terms ani is 5x squared may kanang 10x negative 10x squared. So 5x squared minus 10x squared. So may mo siyang negative 5x squared. Then copy positive 2x and negative 20 over x squared minus 4x raised to the power of 2.
So let's hop on the last example. Find the derivative of f of x is equal to tangent x over x squared. So our u of x is tangent x and our v of x is x squared. Then let's take the derivative of u and v. So u prime is equal to secant squared x, then v prime is equal to 2x. So in u prime, we use the trigonometric identities in derivatives. So let's now proceed in using the theorem 6 or the quotient rule. So f prime of x is equal to v of x times u prime of x minus u of x times v prime of x over v of x squared. So let's now substitute everything to the quotient rule. So f prime of x is equal to x squared times secant squared x minus tangent x times 2x over x squared squared. So x squared times secant squared x is equal to x squared secant squared x. Then minus tangent tangent x times 2x is equal to 2x over tangent x. So the denominator also we can simplify this. So x squared squared is equal to x raised to the power of 4. And now we can factor out the numerator by placing x outside, 1x outside. So it will become x times x secant squared x minus 2 tangent x over x raised to the power of 4. So we can cancel out this x at first and 1x at the denominator. So the final form of this function is x secant squared x minus 2 tangent x over x cubed. So x raised to the power of 4 is simply reduced with 1x or subtracted by 1x. So it became x cubed. And that's all.